Welcome to page 2 of section 2.5. Here we go. Find all the zeros of the function. Now understand the section we're in is fundamental theorem of algebra, and they're talking about the complex number system. And this is big for us. Linear factorization theorem tells us how many exact zeros we're going to have. I'm going to have 2 zeros of this. Now I don't know whether they're real or not. So what I would like to do, I'd like to try to factor this. In fact, they actually want us to get linear factors, but we might find the zeros first. We'll see how that goes. So can I factor? Are there factors of 23 that add up to 10? No. So if I set this equal to 0 and go to quadratic formula, I get x equals the opposite of b, -10 plus or minus square root b squared 100 minus 4 times a1 times c23. 4 times 23 is 92, all on 2a2. So that is -10 plus or minus square root of 8, which means I have real zeros. The imaginary zeros would be if the discriminant was negative. So this is -10 plus or minus square root of 8. 8 is 4 times 2, so the 4 square root is 2, leaves behind a 2 on 2, and we're not going to mess this up. I divide the whole top by 2 and the whole bottom by 2, reduce the whole fraction by 2, and I get -5 plus square root of 2, but plus or minus. Now for the linear factors. The linear factors would be x minus 5 plus square root of 2. Now this is the only time I'm going to do it this way. X minus 5 plus square root of 2. I'm going to omit that step in the future. You'll see what I'm talking about. And x, oh, that's actually a -5. X minus -5 plus square root of 2. And x minus all of -5 minus square root of 2. And here's what I would normally skip this step right here. I'm going to go ahead and do the distributing. So x minus a negative, that's plus 5, minus and positive, that's minus square root of 2. Distribute x minus negative, minus minus plus, so that's x plus 5, minus to minus plus square root of 2. So there's my linear factors of that. Okay? Now, if I could factor first, I'd get the linear factors. And in this case, I've got 2 terms. If I've got 2 terms, here's what I'm hoping. I'm hoping it's minus between there, and I'm hoping it's a perfect square minus a perfect square. And this is, so this is 9y squared, yikes. This is 9y squared plus square root of 625 is 25. If I had 24 quarters, 24 of these, I'd have $6. 25 quarters, $6.25. And 9y squared minus 25, if I set that equal to 0, this is factorable. If you paid attention in the last section, or if you recall, I'm sure you paid attention, but if you recall from the last section, the sum of perfect squares is factorable. Just like the difference, it's going to be 9y plus and 9y minus. It's going to be 5 and 5, but we need the i's. Now, until you're comfortable with it, it's probably worth foiling and seeing. I get 81. Let's see. Oh, this is 3. This is 3. I'm sorry, I looked up there. 3 and 3. I bet you saw that. So, glad I checked. So I get 9y squared minus 15i, but plus 15i, and plus times minus, minus 25, but I squared -1, and we're good. And this one factors traditionally. Difference of perfect squares is 3y plus 5 times 3y minus 5. And there's my linear factor answer right there. A little sloppy, but right there. And now my zeros are x equals, I'm going to go with this one first. I add 5i, divide 3, so that's 5i on 3, or 5/3 I. I subtract 5i, so that's plus or minus. And for these ones, I add and subtract 5 and divide 3. Add 5, divide 3, subtract 5, divide 3. So there are my 4 zeros. Here are my 4 linear factors. Okay, so if I can factor them, I'm going to factor them, especially when it asks me to show the linear factors. Sometimes you need to get the zeros first to find the factors. But here we have 3 terms. It's a polynomial. I'm hoping it's quadratic. Not quadratic on x, but it is quadratic on x squared. So maybe it factors into x squared something and x squared something. Factors of 100 that add up to 29, 4, and 25. Set that equal to 0. Sum of perfect squares. Oh, all right, I'm getting good at this. X plus 2i, x minus 2i, x plus 5i, x minus 5i. So x equals add or subtract 2i, plus or minus 2i. Add or subtract 5i, plus or minus 5i. So there are no real zeros. Can that be possible? Well, let's see. This graph would be up at 100, going up really steep, and going up again. So yeah, it just starts up and just goes up. So there's no real zeros. We can't see these, but there are 4 imaginary zeros, as we knew there should be. Okay, 30 gets us a chance to review our factoring by grouping here. Factoring by grouping. If you will just check this first, you'll know if 4 terms can be factored by grouping like this. Here's what I'm thinking. 3 is to negative 2, or 3 is to negative 2. Does that equal 75 is to negative 50? And we can hopefully quickly see, yes, those are equal. It will factor by grouping. If 3 is to negative 2 is the same as 75 on negative 50, we got it. Therefore, I'm going to factor out an x squared out of the first 2 terms. I get 3x minus 2. And if I will do that ratio or proportion test, I should know I'm going to get 3x minus 2. How do I get it? Factor out a plus 25. And this is what messes with some people. I'm going to try to do my best explaining it. Now, if I factor this out, let's say it was just a here and a here. I'd factor out a, and I'd be left with x squared plus 25, so I'd get a times quantity x squared plus 25. Well, it is a, it's just messier. I'm going to factor out 3x minus 2 from both terms, just like it was a, and I'm left with x squared plus 25. And our new trick, the sum of perfect squares, x plus 5i, x minus 5i. There's my linear factors right there. By linear, I should talk about this. It means all of these are to the first. These are not linear factors. This is, but this is not. That's a quadratic factor or a parabolic factor. So x is add 2, divide 3, add and subtract 5i. And there we go. Now, 34. Here's where we're going to be able to use, I'm going to allow you to use your calculator. Take a note, 3 is to negative 4 is not the same as 8 is to 8. This will not factor by grouping. So we got to come up with some other process, and here's what you would have to do without your calculator. You'd have to use you'd have to find possible rational zero test by taking the factors of 8 on the factors of 3 and start synthetically dividing those. But I'm going to allow this. Let's go. Let's clear that one out. Let's get you where you can see it. 3x to the third minus 2x squared plus 75x minus 50. We got some decent sized numbers there, but I'm still going to give Zoom Standard a chance. I'm looking for zeros here. And I've got one. I'm going to double check my equation. 3x cubed minus 2x squared plus 75x minus 50. Oh, that's the wrong one. Yes. How about this? 3x squared minus 4. Looking at the 3x cubed minus 4x squared. Glad I double checked. Plus 8x plus 8. How does that look? That looks better. I'm going to give that one a chance. And I actually have a 0, and it doesn't look necessarily like I have another 0. Maybe the graph eventually comes back down, but I do have a 0 over here. I'm curious. It doesn't look like it's real pretty, but let's take a look. This is really a lot of what we're going to be doing shortly. So I'm going to go second calc 0. I have to get to the left of that 0. I'm moving to the left. I'm to the left of the 0, stamp enter. Move to the right of the 0, stamp enter, enter. And right now, I recognize this. This is very likely negative 2/3. Very likely. I expect negative 2/3 is a 0. Here's what I'm going to do. 3, negative 4, 8, 8, negative 2/3 synthetically. Now, you say it's a lot of work. Well, back in the day, we would have had to just randomly, without the graphing calculator, we just randomly guess, hey, does 1 make it a 0? Does 2 on 1 make it a 0? Does 4 on 1 make it a 0? Does 8 on 1 make it a 0? Does 1 on 3 make it a 0? Does 2 on 3 make it a 0? And then try the negatives. We used to have to do that, so absolutely no doubt a big hug your calculator moment right now. So here we go. I think that's going to be 0 over here. I certainly hope it is. Let's see. I get bring down to 3 times negative 2/3. 3's cancel, negative 2. Add them, negative 6. Negatives cancel, 12 on 3, 4. Add them, 12. Positive times negative, negative. 12 divided by 3, 4, times 2, 8, 0. So there we go. So right now we can factor this into x minus negative 2/3, x plus 2/3 times 3x squared minus 6x plus 12. Now notice this. If you've got a fraction here, this happens a lot. You can factor a 3 out of here and combine it and take the 3 out of here, put it in front, then distribute it just into this factor. So if I take a 3 out, distribute it here, I get 3x plus 2. Oh, that's nice. Times x squared dividing out the 3 minus 2x dividing out the 3 plus 4. And now, can this factor? Well, factors of 4 that add up to negative 2. No, so I think I'll put it up here. Just looking at this one right now, because I've got to get that down to x to the first, linear factors. So x equals the opposite of b, 2 plus or minus square root of b squared 4 minus 4 times 1 times 4 minus 16 all over 2, which is 2 plus or minus, let's see, that's negative square root negative 12 on 2. Can we reduce the 2 and the 2? This 2 is not a factor of the top, it's just a term. All right, so we have imaginaries. This is 4 times 3, 2 plus or minus, square root of 4 is 2 leave the 3 in there, and there's an I, and notice I keep that I separate from that square root. All on 2, or, so if we have those, I guess I can reduce it here, or reduce top and bottom by 2, 1 plus or minus square root of 3 times I, and my other 0 is negative 2/3. Subtract 2, divide 3. So there's my zeros, x equals. Here's my factors. Well, the easy one was this 3x plus 2, but this one factored, or if I was going to factor, these are the things these are the zeros I would get. So I need x minus, I'll do the plus one first, minus distribute it to 1 plus square root of 3i. That's minus 1 minus square root of 3i. And then distribute the minus to the 1 minus square root of 3. That's x minus 1 plus square root of 3i. That's what we're going to do. Okay, now guess what we're going to do on 36? We're going to graph that. We're going to try to find at least a couple of zeros. We're going to synthetically divide, and we're going to write small. So grab your calculators, beat me to it. Let's go ahead and get this graphed. Graphing is a skill. We need to practice it. Graphing even with our calculator is. So x to the 4th plus 6x cubed. And you're going to notice that I didn't draw the graphs for these, and I say most of the time when you go to your graphing calculator on your homework, I want you to draw the graph. It's not important that you do, because you're going to show me for sure that you've drawn the graph on your assignment when you show this type of work, this synthetic division. I'll know you've seen the graph. So here we go. Plus 10x squared plus 6x. Go back to that. Make just my general rule is whatever I do here on the right side of the page is what I'm expecting you to show on the left side of the page. So double check. Let's graph that. Let's hope we can get at least a couple decent zeros here. Ooh, interesting. Take a look back here at negative 3. I'm going to zoom box around that. Still graphing. Zoom box. It looks like there's a 0 at negative 3, but that's kind of a misnomer there to say it looks like there's a 0. It actually looks like there might be 2 zeros there. Boy, it's worth giving it a shot twice. I'm going to synthetically divide negative 3 through here and see if that's a 0. Negative 3 into 1, 6, 10, 6, 9. Goes in once times negative 3. Add them 3 times negative 3. Add them 1 times negative 3. Add them 3 times negative 3. Yay. Now, 1 is to 3 as 1 is to 3. You could synthetically divide this by negative 3 again, but this is going to be factorable by grouping. So it's entirely up to you. I'm going to divide negative 3 again, because maybe that wouldn't always be a possibility, but I'm telling you this would be factorable by grouping. 1 multiply negative 3, 0 multiply 0, 1 multiply negative 3. And we've got 0. So here's our factors so far. X plus 3 squared goes twice, and then I would be left with an x squared, no x's, and a 1. How about that? And this is now factorable. So I get x plus 3 squared times x plus 1i times x minus 1i. If I set that equal to 0, by the way, there's our linear factors, I get x equals negative 3. I like to state its multiplicity 2. At times the book will. I'll make certain that it's clear whether I'm expecting that for you. The way they word it here, we don't have to. but it's not a bad habit to get into. And plus or minus I. So you got a little bit of work to do on this one. That was a 20-minute video with explanation. I would assume that you'd kind of be in that same ballpark. Some of you are going to be quicker, and some of you probably going to want to ask some questions. Let me know how I can help.